a bear destroying a computer. And you know, it's once
I love
you
this gift, man. Yeah.
yeah it's once you really you want to take this notebook and then productionize it, what do you do with that? And so let's see how Hermione can help us with that, and using her magic.
Okay, I'm just gonna share my screen with you guys.
Perfect.
When you see it, give me an okay.
Yep, we can see it.
Okay, great. I'm just gonna show you. I'm just gonna explain some things. Very few words about Hermione before. Okay. Then I'll show. We will do a quick live demo here. Okay.
Nice.
So Hermione. Okay. So this is me. Hello, everyone. If you want to reach out to me, you have LinkedIn, Twitter, Neylson Crepalde. With a name like that, it's not difficult to find me. But anyway, okay. So we already talked about this. Then we have very different scenarios when you're doing data science Kaggle style, if I may say so, and professional style. This was what we were talking about, the problems with code patterns, with organization redundancy, with code quality, lots of manual work, the abyss that we have between experimentation phase and production phase. Okay, so this is when Hermione comes to the rescue. This is where she can help you. So what is Hermione? After all, she provides you a structure for you to build your code on top of it that endures code reusability, that makes you think about and code unit testing, and helps you prevent errors. You know, this is something that I would like to highlight here, because unfortunately there are some clients, some people that we have worked, that they have this amazingly difficult goal of reaching a project that is flawless. And this is just impossible. This does not exist. Things will fail at some point. The main question is not that if it's gonna fail, it's when it's gonna fail. When is it going to fail? And when it does, am I ready to deal with it? Can I mitigate some of these flaws that we have? Can I recover fast enough? So Hermione, in structuring the projects, she helps you think about that. Also, in Hermione, we have the implementation of some data analysis tools and some machine learning techniques. That's reusable code. So some functions, some methods that we have developed to make things easier, to make plots and to investigate the data set. We already pushed that along with Hermione for you to speed things up a little bit. And we use MLflow to track experimentations and log metrics and artifacts. We have a very romantic heart there, just a little joke, because we really like MLflow and what it does for experimentation. But guys, it's very important to state that we do not have any contract or partnership with MLflow or Databricks. We don't get money talking about it. It's just a choice that we made. It just seemed like a very reasonable choice.
But and when they want to give you some money, yeah. I'm sure. If they want to give you some money for talking about them so good, you wouldn't turn it away, I imagine.
I would not mind that, actually. Yeah.
There, you heard it. Databricks, anyway, where you at?
So. But anyway, when we were building her, we experimented a lot of tools. So we played along with Kubeflow, with Netflix's MetaFlow, with DVC, with Pachyderm, with Kedro. There are a lot of very good tools for MLOps. I think the last talk that we had, you talked exactly about it. The difference between MLflow and Kubeflow, and what one does, what the other does, is not exactly the same tool.
Yep. Shout out to Byron. I think he's in here somewhere. That was a great talk.
Great conversation.
Yeah.
Yeah. But what happened with MLflow is that we needed, so Hermione is a structure that must allow you to build on top of her. So it cannot be something so big that instead of making your life easier, it like makes you tight, you know. That was not the point. So we develop Hermione in a way that she helps you build stuff, but if you have another opinion, if you want to do things another way, she's opened enough so you can just reshape her the way that you would really like.
Because
So MLflow was chose exactly because it's a little bit more we found it a little bit more integrable, more
and when you were working with other ones like DVC or these other platforms that you were talking about, it wasn't as flexible in your opinion?
Yeah, that's it. It wasn't that flexible. DVC is a great tool. Kubeflow is a great tool. We use it sometimes, but Kubeflow DVC, it's like at least in my opinion, it seems like you have to choose it and use it as it is, and you adjust to it. You know,
Yeah, it's very
Casual
binary.
also. Yeah, those are great tools. I really love them, but I feel like I have to adjust to them. And when we were building Hermione, we wanted to build a tool that can adjust to your needs, not the other way around. So MLflow was a logical choice for that because it's very, very flexible, very easy to use. Okay, so this is how Hermione works. Okay, we have some classes built here. I'm gonna show you with this pointer here. So everybody begins with this class here. That's data source. So data source is an abstract class. Then we have two classes that inherits from data source. That's spreadsheet and database. If you have data that you have to import from spreadsheets, you can develop your imports here in this class. If you have databases, you can code your connections and get your and do your queries in this class. Okay, so besides data source, we have this other class, very important class, that's pre-processing, and all the pre-processing steps should be coded inside this class. So all the methods that you have, you can call this class and its methods to do it. I'm going to show you right away how we do it with Hermione. And attached to this class, we have some classes already coded. We have a normalization class and a text vectorizer class. Again, this is like a general class that you are going to build stuff on top of it. And this, the text vectorizer and normalization, are some things that we already had to do for some project that we decided to launch with Hermione, just to people use if they want to. You know, this is our already ready functions. You know, then we have this other class here, that's visualization. Also, it's a tools class. It has some methods that are already usable. So you can just do several things of regression analysis, build a lot of plots, check residuals distribution, those kind of stuff with just one method. And some other stuff we had already made this available for you, and you also have space, of course, to build your own visualizations, your own plots. You can build it all here in the visualization class. And then you have the train class. Actually, sorry, train is not a class. Train's a module. Train's a script. This is like your main function, okay? This is where you are going to put everything to work, okay? Train is built on top of data source to get your data, on top of pre-processing to transform and do your feature engineering process and stuff. And the train method calls the trainer class. The trainer is another abstract class, and trainer in some other classes that you are going to actually use when you code inherit from trainer. So for each algorithm or each method that you have, you can build this kind of class. We have, for example, here a trainer sklearn, so a class to use scikit-learn algorithms. If I use, for example, XGBoost, I would implement a trainer XGBoost. If I use PyTorch or TensorFlow or wherever, I would build a trainer TensorFlow, a trainer PyTorch, or whatever you have. You also have this class metrics with metrics already implemented for you. So the idea is that when you train a model, the result, the object that you have on the very end is this one, the model wrapper. The model wrapper actually is a dictionary containing the model itself. It contains the pre-processing object that was used to do all the pre-processing steps. It contains the metrics, supposing that you do train test split, do things in this way, you would have all the metrics for test runs inside this object. And we put also the columns that were used to build this model. This is something very useful. We had lots of problems in the past regarding different columns or columns in different order, so we have this here in this wrapper, this model wrapper class. It has this methods, predict, probe, you can save model, load model, you can get metrics and stuff. And the interesting part is that this wrapper class, it is an MLflow Py function class. So it's totally recognizable by MLflow, if I may say so. So, for example, you can just get your results, your wrapper object, and then treat it like a MLflow model and do stuff with MLflow that you would do in a regular basis. You can deploy it anywhere you want. You can take advantage of MLflow's built-in API, or you can build your model in a Docker container and send it to AWS, into Azure ML, into Google Cloud, or whatever. Anyway. So that's it. This is the structure, okay? And this structure is designed like this. So you have these folders, data, when you are supposed to put your audio data. If you have pre-processed data, you can have a subfolder here, pre-processed, or you can build it any way you like. Then raw data, you should put it here. You have a folder for outputs. So models, figures, plots, those kind of stuff you can put here in output directory. You have the requirements for the project. You have a README for the project. You have the conda env for the project. Hermione already builds that automatically for you. You have the source folder. This is the code itself. So inside the source folder, you have the train script that is your main function, the thing that's going to build everything, to put everything together. You have an util.py util.py script, some helper functions that you want to code. They can go here. You have a config folder with a config file. In Hermione, usually you put here the name of the project, the name of the developer, some environments, and if you want to have more stuff in the config file, you can just develop on top of it. You have tests folder, and this is a test. That's not a JSON actually. It's a .py. It's a .py file. Sorry, it's not correct. But you have a test class. So you can code unit tests for your project. Then you have ML folder, and in the ML folder is all that structure that we talked before. So we have data source and the classes here. You have a folder notebooks, and you have an example notebook you have the visualization folder with the visualization class. You have pre-processing, the pre-processing class, and the normalization and text vectorizer classes, and the model folder with the trainer class, with the wrapper class, and the metrics class for you to control. Okay, so
Cool.
let's get to know her.
Yeah. Before we jump into it, I see Sumita had a question in the chat and was asking, does the wrapper with MLflow also include log model, where the model can be registered and its model lifecycle can be changed?
Yeah, it does on top of MLflow. It does not do it automatically. You have to code your logs, but it has it actually. I'm just gonna show you right away how you can do that. Okay.